Assalamu alaikum dear students. Today I am going to take here a lecture of class 12th, and that lecture is related to relationship between drift velocity of electrons and electric current. That question is very important, and hope you can enjoy this question because this question is very simple. To establish the relationship between Vd, that is drift velocity of electrons, and electric current, I will take here like this. I will take here a conductor in the form of a cylinder. Let this conductor is having length L and having cross-sectional area A. I am taking a conductor made up of conductor made up of copper or any metal. Let the length of the conductor is L and A is area of cross section. Let dear students, this end of the conductor is connected to the positive of the battery, and dear students, this end of the conductor is connected to the negative of the battery. Now first of all, it is very easy. Let L is, what is L dear students? L is length of the conductor. Length of the conductor. तो बेटा मैंने क्या लिखा यहाँ? L क्या लिखी? L लिखी मैंने length of the conductor. तो A क्या है बेटा? What is A here? A बेटा यहाँ है area of cross section. बात आई समझ में? क्या लिखा बेटा मैंने? A is area of cross section. कैपिटल A से डिनोट किया. And dear students, we know that when we apply potential difference across the ends of the conductor due to this battery, because this end is connected to the positive of the battery, and dear students, this end is connected to the negative of the battery. So once we give potential difference across the ends of the conductor, current flows through that conductor. We know this. The direction of conventional current is from positive to negative throughout this circuit. But we know that we have already derived the expression for drift velocity of electrons, that electrons get drifted, they move towards the positive of the battery with the velocity Vd, and that velocity is known as drift velocity of electrons. And we have discussed this drift velocity of electrons, and we have found expression already for drift velocity of electrons, and the expression for drift velocity of electrons is E, that is electric field, divided by m into tau, relaxation time, and the definition of drift velocity of electrons is the average velocity of all the electrons with which they get drifted towards the positive of the battery. And that average velocity of all the electrons in the presence of electric field, that is electric field here is present, it is from positive to negative. Direction is from positive to negative. So the average velocity with which electrons get drifted towards the positive of the battery in the presence of field, electric field, is known as drift velocity of electrons. And I have already told you about this thing, and I have already found expression for electric field. So dear students, now let L is the length of the conductor, A is the area of cross section. This is the area of cross section of the conductor, dear students. Again, N is number density of electrons. And what is number density? Density, that means number of electrons per unit volume. Number density means number of electrons per unit. Per means beta यहाँ divided per unit volume. See dear, N is number of electrons per unit volume. इसके unit volume में कितने electrons हैं बेटा, and that thing is known as electron density. Now see dear, it is clear now. What is the volume of conductor? Volume of conductor. बेटा इस कंडक्टर का कितना वॉल्यूम है? this conductor की शक्ल, that this conductor is in the form of a cylinder. So we know that the volume of cylinder is equal to area of cross section into length of the conductor, because pi r square L, this A is equal to pi r square because it is a circular shape, and the volume of this conductor is equal to pi r square into L, but pi r square is the area of circle, that is area of cross section here, not circle but in the form of a disc. So volume of conductor is here A into L. A is area of cross section and L is the length of the conductor. Now see, dear students, N is here electron density, that is number of electrons per unit volume. इसका मतलब बेटा ये है कि in unit volume, unit means one in unit volume, one volume, number of electrons, बेटा कितने हैं number of electrons? N, because N is the electron density, that is number of electrons per unit volume, that means in unit volume इस कंडक्टर के यूनिट वॉल्यूम में कितने इलेक्ट्रॉन्स है बेटा? N. बट वॉल्यूम ऑफ द कंडक्टर कितने हैं? Al. Therefore electrons in the conductor, therefore total electrons in the conductor, here conductor is in the form of a cylinder. In the conductor is, because in unit volume number of electrons is N, therefore total electrons in the conductor is, because the volume of the conductor is Al, therefore in volume Al, the number of electrons is N into A into L. Because in unit volume number of electrons is N, therefore the total electrons in the conductor having volume Al is equal to N into Al. That is very simple. N is the number of electrons per unit volume, and A is area of cross section, and L is the length of conductor. So these are the total number of electrons there in this conductor. Hope you have got this point. Now the next point here is like this. We know, dear students, क्या हम जानते हैं बेटा? Charge on one electron. कितनी होती है charge on one electron बेटा? वो होती है E. माइनस E होती है, लेकिन मैं मैग्नीट्यूड लेता हूं तो माइनस नहीं लूंगा, तो सिंपली आई एम टेकिंग E, and that E is equal to 1.6 into 10 raised to power minus 19 coulombs. Charge on one electron therefore is E, but the total number of electrons in the conductor is Nal, therefore total charge in the conductor, therefore total charge in the conductor is equal to N into A into L into E. Because charge on one electron is E, but the total number of electrons in the cylinder is, in this conductor is Nal, therefore charge on these electrons or charge in the cylinder is equal to total charge in the conductor or cylinder is N into Al into E, because these are the total number of electrons in the conductor and charge of one electron is E. Therefore बेटा यहाँ टोटल चार्ज कितनी होगी इस कंडक्टर में? टोटल चार्ज होगी N into A into L into E. I hope you have got this, and I can write this charge to be as Q, because this is the charge in the conductor. I am writing this by Q. मैंने बेटा ये Q से लिखी, तो मैंने बेटा यहाँ N into A into L into E. So I am writing Q is equal to N A L E. What is this charge? This is the total charge there in this conductor or there in this cylinder. So I am writing this by equation first. Hope you have got this. Now see here. We know, बेटा हमको पता है, क्या बेटा पता है हमको, that I is equal to Q by T. We know that electric current is charge flowing per unit time. Write this as equation second. Therefore बेटा substitute फर्स्ट इन इक्वेशन सेकंड. पहली को किसमें सब्स्टिट्यूट करो बेटा? दूसरी में. पहली इक्वेशन को बेटा सब्स्टिट्यूट करो, किसमें करो? दूसरी में करो सब्स्टिट्यूट. तो बेटा क्या आएगी? देयरफॉर I इज इक्वल टू Q के बदले क्या लिखो बेटा? NaLe divided by T, and write down it as equation number third. That is very simple and important. Now again see my dear students. if I am assuming here that the electrons are moving from this end to this end with the drift velocity of Vd, and I know that L is the length of the conductor. So the time taken by the electron to move from this end to this end is given by, that is we know beta क्या पता हमको, that drift velocity of electrons, that is v here is small d, is equal to L by T, where L is the length of the conductor, that is here distance or displacement, and T is the time taken by the electron from moving from this end to this end, and Vd is equal to displacement or distance but a time. If talking velocity, then displacement. If about speed, then it is distance by time. Okay, this is straight here, no problem at all. So therefore, my dear students, I am writing this like, so Vd is equal to L by T. Therefore बेटा यहाँ आएगा T किसके बराबर आएगा, T यहाँ इसको ले जाओ और ये बनेगा बेटा यहाँ T को यहाँ ले जाओ और इसको यहाँ ले जाओ, ये यहाँ जो नीचे था नीचे वाला यहाँ ऊपर जाएगा, लेकिन यहाँ ऊपर वाला यहाँ नीचे जाएगा क्योंकि यहाँ ये डिवाइड हो जाएगा और यहाँ ये मल्टीपल हो जाएगा, तो L बाय हम लिखेंगे बेटा Vd, और इसकी देखो इक्वेशन नंबर 4। नाउ सब्स्टिट्यूट इक्वेशन 4 इन इक्वेशन 3। अब बेटा आप क्या करो, इक्वेशन 4 को इक्वेशन 3 में सब्स्टिट्यूट करो जल्दी करो बेटा, जल्दी करो। तो क्या हो जाएगा, सब्स्टिट्यूट 4th इन इक्वेशन 3, देयरफॉर 3rd बिकम्स, क्या बेटा बनेगी 3rd, बताइए बेटा क्या बनेगी, अरे ओ बेटा ओ छोरिया बता क्या बनेगा, तो क्या बनेगा बेटा I इज इक्वल टू NaLe, और T के बदले क्या लिखूंगा, T के बदले बेटा लिखूंगा L by Vd, T के बदले लिखा L by Vd, वेरी सिंपल। Therefore students, I am writing here I is equal to NaLe, but here it is L by Vd. When I am writing this into this, ये जो नीचे वाला होगा ये ऊपर जाएगा बेटा, और ये ऊपर वाला नीचे रेसिप्रोकल हो जाएगा इसका। Here it is L. I am very sorry, this is L actually, L। तो बेटे ये L और L कैंसिल हो जाएगा, therefore I किसके बराबर है, I is equal to N, मैं फिर लिखूंगा E, फिर लिखूंगा A और V, that is the velocity of electrons। This is very beautiful relationship between drift velocity of electrons and electric current, but in magnitude form. I have written this equation in magnitude form. See my dear students, so hope you have got this question. This is very important. I have seen so many times this question to be in the board exam, and there are also numericals that are also posed there in the competitive exams related to this relation. That is very important, but you should keep this in mind that I is electric current and N is the electron density, not total number of electrons. It is the electron density, that means number of electrons in unit volume of this conductor, and EA is the area of cross section, that is this, and Vd is drift velocity of electrons, and E is the magnitude of charge of an electron, and that is 1.6 into 10 to the power minus 19 coulombs. Hope you have got this question. Now next question here is Ohm's law. Next question here is Ohm's law. Now the question arises here, before doing Ohm's law here, that's my next topic and is most important topic here, but before this I will throw light on this relation. Sometimes some students pose the question that sir, if the drift velocity of electrons is 10 raised to the power minus 4 meter per second, then how it is possible, because in conductors the electric current is due to drift velocity of electrons, but if it is only of the order of 10 raised to the power minus 4 meter per second, then how it is possible that a bulb shines or glows instantly when we close the circuit, when we on the circuit? How it is possible when the speed of electron is, drift speed of electron is only 10 raised to the power minus 4 meter per second? बेटे बात ये है कि जो electrons इसमें filled हैं, when we apply here positive, this end to the negative. We supply, actually it does not supply electrons, it supplies energy, because potential difference means potential energy, it supplies energy to this. And due to this, but this energy here travels in the form of electric field, and there is setup of electric field inside at each and every point. Here these electrons are localized, but about their mean positions, they move with the speed of, they don't go from this to this, actually they move with a speed about their local positions with 10 raised to power minus 4 meter per second. But this electric field is set up instantly within time of within no seconds, instantly, and this energy, this electric field in the form of energy, travels with a velocity of 3 into 10 raised to power 8 meter per second. Thus the current is established here with the speed of 3 into 10 raised to power 8 meter per second. That is why a bulb glows instantly, although the drift velocity is 10 raised to power minus 4 meter per second. This is just like, I can give an example here. It is, and this current is moving, that is electric field is propagating here in the form of a wave, and that wave has, that is an electromagnetic process, and that electromagnetic wave travels with the velocity of 3 into 10 raised to power 8 meter per second. But about their mean positions, about their local positions, electrons have their speeds of 10 raised to power minus 4 meter per second. It is just like a wave, when just like a mechanical wave, when a mechanical wave is propagating from one end to the another end, while the particles are vibrating about their mean positions. Here it is not like this, but I am explaining this like this, that these electrons are vibrating about, these are moving rather with the speed of this, but this electric field, that is electric current, is established within no time, and that is why this bulb glows. Now my next topic here is Ohm's law. See, dear students, hope you have got this question. Now the next question is Ohm's law. What is Ohm's law here, dear students? I am again taking a conductor here, and this end, let A is the area of cross section and L is the length of this conductor. Let this end of the conductor is connected to the positive of the battery, and this end is connected to the negative of the battery. See here? And conventional current moves from positive to negative, while as the electrons move from this end, that is from negative to positive. And electric field is set up inside each and every point due to this battery, and its direction is from positive to negative. Clear? Now what is Ohm's law? Ohm's law states that the potential difference applied across the ends of the conductor is directly proportional to the current flowing through this conductor. This E establishes here potential difference, that is V between the ends A, and between these ends, let us say this is P end and this is Q end. Across the ends of this conductor, this battery sets up a potential, and that potential is due to this the electric field, and that potential difference is responsible for the current. We know that current flows due to the potential difference, as we know that heat flows due to the temperature difference in thermodynamics, and similar is the case in the hydrodynamics, that fluids move due to the pressure difference. If there is no pressure difference, fluids will not move. If liquids do not move, gases will not move. If there is no temperature difference, बेटा कोई करंट, कोई हीट करंट नहीं चलेगी, कोई हीट नहीं चलेगी. Here is same rule. The temperature that plays role there in the thermodynamics, same role is played by potential difference here in electrodynamics or in electric current, electricity. See, dear students, now as we increase this battery, voltage of the battery, there is increase in the current. That is Ohm's law. What Ohm's law states? It states statement for this. It states that the potential difference applied, the potential difference applied across the ends of conductor, applied across the ends of conductor of a conductor is is directly proportional is directly proportional to the voltage applied across the ends of conductor. Voltage or potential difference applied across the ends of the conductor. Provided physical conditions should remain constant, provided temperature, pressure, mechanical strain should remain constant, then it is true, otherwise it is not true. This is the statement for Ohm's law. That is, the statement is the potential difference applied across the ends of the conductor, it is due to this battery, is directly proportional to the voltage. Is directly proportional to the not voltage beta, it is directly proportional to the current across the conductor, not across the ends but across the, sorry dear students, directly proportional to the current across the conductor, तो बेटा क्या लिखा मैंने यहाँ कि जितनी पोटेंशियल डिफरेंस ज्यादा होगी इतना ही बहाव यहाँ होगा करंट का, लेकिन इलेक्ट्रिक करंट का, चार्ज फ्लो का, एंड दैट लॉ इज नोन एज ओम्स लॉ, स्टेटमेंट फॉर ओम्स लॉ. तो जितनी पोटेंशियल डिफरेंस होगी, जितना पोटेंशियल डिफरेंस हम अप्लाई करेंगे, जितनी वोल्टेज होगी, इतनी ही क्या बढ़ेगी इसमें, इलेक्ट्रिक करंट. सो पोटेंशियल डिफरेंस अप्लाइड इज इक्वल टू द करंट फ्लोइंग थ्रू दैट कंडक्टर, एंड दैट लॉ इज नोन एज ओम्स लॉ. But for ohmic conductors, what are ohmic conductors? Those conductors in which resistance remains constant. And this law is applied. This law is applied when resistance of the conductor remains constant, and that remains constant when temperature, pressure and mechanical strain do not get changed. बेटा अगर ये चेंज हो जाएंगे ना, टेम्परेचर या प्रेशर या मैग्नेटिक स्ट्रेन, इससे चेंज आती है रेजिस्टेंस में, वो आगे वाले टॉपिक में पढ़ना है. लेकिन यहाँ रेजिस्टेंस क्या होनी चाहिए, कांस्टेंट. ये तभी कांस्टेंट होगी जब ये चीजें कांस्टेंट हैं. तो एट दैट टाइम ये वोल्टेज जो हम यहाँ अप्लाई करते हैं अक्रॉस द एंड्स ऑफ द कंडक्टर, तो ये डायरेक्टली प्रोपोर्शनल है कि कितनी चलेगी यहाँ करंट, दैट इज चार्ज फ्लोइंग पर यूनिट टाइम. दैट इज नोन एज ओम्स लॉ, स्टेटमेंट फॉर ओम्स लॉ. तो V इज इक्वल टू हम लिखेंगे बेटा यहाँ RI, where R is the resistance of the conductor. For ohmic conductors this remains constant, where R is resistance of the conductor, where R is the resistance of the conductor. Therefore I am writing this thing, V by I is equal to R, but for ohmic conductors के लिए ये क्या, ये R रहता है बेटा किनके लिए, कांस्टेंट, किनके लिए, फॉर ohmic conductors. एंड ohmic conductor क्या है, जो फॉलो करते हैं Ohm's law. That means what is Ohm's law? Ohm's law is not this relation. This relation is not Ohm's law. Ohm's law is this, that potential difference is directly proportional to the current. But for ohmic conductors this R remains constant. तो relation आती है V by I is equal to R. And this R should remain constant. R should remain constant for ohmic conductors, and then at that time voltage is directly proportional to current. And now I am going to derive this, and after that I will explain its graph. See my dear, derivation of this law. Derivation is very simple my dear students. We know, क्या हमको पता है बेटा, आपको पता है कि ड्रिफ्ट वेलोसिटी होती है या I होती है. We know I is equal to NEABD. अभी हमने रिलेशन निकाली, that electric current is equal to I is equal to NEABD. N is the electron density, is charge of an electron, is area of cross section, this area of cross section, and VD is drift velocity of electrons, and I is the electric current, that is conventional current. moving from positive to negative. See now, we know this. Right is that equation first, but we also know, हमको बेटे ये भी पता है, क्या पता है हमको, but we also know, क्या पता है कि VD is equal to E, that is this electronic charge, is electric field, divided by m is mass of an electron, and tau is the average relaxation time. Already discussed this thing. It is equal to tau 1 plus tau 2 plus dash up to tau n divided by n, and that comes out to be, as stands for, minus 14 at room temperature. So let it be, and that is here second equation. But we also know बेटा, हमको क्या पता है, क्या बेटा हमको पता है कि ये E किसके बराबर है, V by L. That is potential difference between this and this is V, but it is the distance between this point P and Q is, this point is P and Q is L, and the potential difference between P and Q is V. So what is the field? This electric field is V by L, that is d by dr. E is V by L, voltage by distance between the points. Now substituting third equation in second. Third को बेटा किसमें substitute करो, second में करो. बहुत आसान क्वेश्चन है, कुछ भी नहीं है, करो substitute. हलवा जैसा क्वेश्चन, बहुत मजेदार, बहुत ही अच्छा क्वेश्चन. तो बेटा क्या आएगा यहाँ, therefore substitute third in, किसमें डालेंगे बेटा, substitute third in second. तो second क्या आएगी बेटा बताइए. VD is equal to E के बदले बेटा लिखेंगे यहाँ V by L, और बेटा मैंने यहाँ M लिखा, तो ये है tau. Hope you have got this. Now see my dear students, तो VD किसके बराबर है, EVML tau. Now see dear students, तो सॉरी ये इसमें सब्स्टिट्यूट नहीं करना था, तो हमने क्या निकाला बेटा यहाँ, देखिए बेटा क्या है. चलो ओके, VD ये किसके बराबर है, E, तो E किसके बराबर है, V by L इंटू बेटा यहाँ tau, बिकॉज E tau by M. तो बेटा नाउ I किसके बराबर है, नाउ I किसके बराबर है, सॉरी, I is equal to NEAVD. नाउ I is equal to NEAVD, therefore ये किसके बराबर आएगा, I is equal to NEA. तो VD के बदले क्या लिखते, सब्स्टिट्यूट करेंगे, VD यहाँ किसके बराबर है बेटा, EV by L इंटू tau, और डिवाइड में बेटा क्या है, डिवाइड बाय M. Hope you have got this. And I is equal to बेटा यहाँ N E इंटू E हो गया E स्क्वायर, A बेटा ये है यहाँ V और tau, और बेटा डिवाइड में M इंटू L. Hope you have got this. Now see my dear students, therefore I किसके बराबर आएगा, I N E स्क्वायर, रिपीटिंग द सेम हियर. A तो पहले बेटा tau लिखूंगा, और tau के बाद इसके बाद एरिया ऑफ क्रॉस सेक्शन एंड डिवाइडेड बाय M इंटू L. तो ये किसके बराबर आएगा, यहाँ में A को, सॉरी यहाँ A नहीं है, तो यहाँ N E स्क्वायर A tau, और बेटा यहाँ V है, वोल्टेज है यहाँ, वोल्टेज डिवाइड बाय ML. तो यहाँ लिखूंगा I बाई बेटा V इज इक्वल टू N E स्क्वायर A, तो बेटा मैंने लिखा यहाँ tau डिवाइडेड बाय ML. नो रेसिप्रोकल ऑफ दिस इज, तो यहाँ हम रेसिप्रोकल लेंगे बेटा, तो रेसिप्रोकल जब करेंगे तो ये V बाय आएगा, तो बेटा यहाँ आएगा ML बाय N E स्क्वायर A tau. होप यू हैव गॉट दिस. बट व्हाट इज दिस V बाय I? V बाय I इज इक्वल टू R. तो बेटा ये चीज जो है ना, यहाँ एक्चुअली ये ऐसे नहीं लिखेंगे, यहाँ V by I is equal to ML divided by N square A tau, but this thing in a particular, in our case, remains constant. Why this remains constant? Because mass of an electron is constant. L here for our case is constant, and that does not get changed because temperature remains constant. So length X, there is no linear expansion. And N is the electron density, that also remains constant. E is the charge of an electron, that is also constant. A does not get changed because there is no surface expansion because temperature remains constant. So tau is also constant here. See my dear students. तो ये क्या आएगा, and that constant, this is a constant, and that constant here we write to be as R. where this R is resistance of the conductor, and that is equal to ml by ne square tau e. So please remember this equation. I have concluded this topic because time is very less, and next time inshallah in my next lecture I will draw it as graph, that is the graph between V and I, and that graph will give me the resistance. But time is because we are not in a position to upload the videos, and hope with this I have concluded the topic. Inshallah I will meet you next time. I will discuss these things. I will do the numericals. I have here explained the basics of this, and inshallah in my next topic I will do numericals. I will explain the graph. I will explain so many things, and hope inshallah hope for the best, and wish me all the best of luck. Okay, nice.